All right, so a quick long division example. Let's take it across. Let's do. Make it x plus 5 into this. So again, sorry. Somebody, yes?
When's it that?
When's the test? Thursday. Everybody okay? I hear somebody going, what? Okay. It's not directed towards me. Yeah. So x times what is 4x squared? 4x. So then you multiply. So you get 4x squared like we knew we would.
20x.
Change the signs. I like it. Change the signs. So then you get negative 26x. X times what is negative 26x? Negative 26. Negative 26 times 5. A lot. And then I change the signs.
Why do you change the signs? Just because?
No, because that's how it works, right? How do you divide? How do you long divide anything? 81 into 6,589.
Oh, so you can find the difference.
Yeah, because so here, what would you do?
You would do 81.
What would you put up here?
Whatever 81.
So, if you do enough long division in your life, you will realize you start to do this, even though that's not really the problem. Which is less and less people do that, though. This is troubling me, but that's all right. 8 in the 65 is 8, so 8's a good first guess. If 8 goes into 65 8 times, 80 goes into 650 about 8 times. That's why it makes sense that I only look at this first, but when I multiply 8, I do it times 8 and 1. Times 80 and 1. So this would be 648. And then you change its sign. Yep. You change the sign of all the numbers that are there. So I change the sign of all the things that are there. There's no step that's different.
Will the 132 be the remainder, right?
Yeah, so this would be 132. So this would be what?
132 over x plus 5.
Sweet. The same way you would do numbers.
Can we use the other solution you showed us? The shortcut?
Synthetic.
So on the test, I'm going to have long division problems. I'm going to have synthetic division. You have to know how to do both.
Can you run through synthetic?
Okay. I was going to say, you're all going to sit there like, students are expected to learn and teachers can't even learn shit? Sorry. Learn to turn that. Oh, learn to turn that shit down. Is that all right? Sorry, wait. Is that all right? Did I answer all the questions about that? So synthetic, in fact, synthetic only works, it would work here, wouldn't it?
Yeah.
What would synthetic look like?
Negative 5.
Negative 5.
4, 6,
4?
negative 6.
Negative 6? 2? Because I'm not missing any terms, right?
Bring down the 4.
Bring down the 4. Negative 5 times 4 is negative 20. Add, multiply, add. That's your remainder term. Yeah. If you missed discussion about this, get help. Come see me. Watch the videos. Something. This is synthetic division. See how this is the same thing? Look, negative 6 minus 20. Negative 6 minus 20. 2 and 130. 2 and 130. That method only picks out the most important parts.
So you brought down the 4 and you...
Bring the 4 down. Multiply. Add. Multiply. Add. Yep. Just like it says on that handout. This is so useful. But again, why is it so easy? Because it only works when you have x plus or minus number. If I would have left that 2 there, this would not have worked. X squared, this don't work. So that's why we still need long division. Okay. I like it. Hey, Mikey. Okay. Anything else from homework stuff or general ideas? Yeah, Carrie.
One of those terms is you skip the power, because x to the fourth minus x to the squared.
Yes, you would put a 0 in place of the x cubed. So for long division, it would be like if you had 4x to the fourth plus x squared, you would say plus 0x cubed plus x squared. You want that place to show up.
Okay, in the homework, I did a problem. When you bring down the zero, then when you multiply any number by zero, it's zero, and you have to carry it over.
No. There's not going to be any multiplication by 0 here.
Or you just...
You mean if it's out here?
Yeah.
Is that what you mean?
No, in the long division.
Okay, it's in here.
You just bring down...
Yeah,
the
so
zero.
for example, if I was dividing this by x minus 1, let's go ahead and give us some more stuff. Okay. Right? So this would be 4x cubed. See, this is why you want this here. Minus 4x cubed here, right? So now I have a place to put it somewhere. There's no multiplying by 0. It's just there, so I have a place to put the x cubed terms. Yeah. If you didn't put it there, you would kind of freak out a little bit, and people would put it underneath this, and somehow they would add together, even though they're not like terms. That's not good. That's why you want that placeholder there.
I have a question on 30 for 5.8. Kind of like the same thing, but smaller.
Oh yeah, like, why are all these empty bottles? I love it. So this one says t cubed plus 27 divided by t plus 3. Sorry? This is from yesterday.
Oh, yesterday, where's today's? Where are those things?
Oh, I'm sorry. Yeah, that's a practice test. Did you not get one? Okay.
I'll take one out.
Sure, good. Okay, where am I again? What was this? This is number, what was this number? 30. And here it just says divide. It doesn't say to use synthetic yet. Because you could use synthetic. Either synthetic or long division, you still have to represent the missing terms. So this would be t plus 3 into what?
Plus t.
0 t's plus 27. Again, if you really think of how do you write the number 1001? What do you write? 1001.
1001.
1001. Why are those zeros there? They're placeholders. Because if I wrote 1001, that's 11. I need placeholders to show that those things are not there. There's no hundreds. There's no tens. There's only 1001, right? So there's only cubes and numbers. So there's 0 of the things in the middle. Don't put a 1 there, because then suddenly you created a t. That's some neat shit, right? And now you just do this like normal. Once you got the zeros there, it doesn't change anything after that. You just got a place to put those terms. So here, t times what is t cubed? T squared times t squared times 3. Change the sign. See, now you got a t squared place. And then you got a t place. And then that's why you want to put them there, so you have a place to line those up. Yes?
Well, what does it matter if it's 0? I don't understand how that gets rid of that. Like, why are you putting it under there?
All right, so if I had this, when you do this, wait, got it. T cubed plus 3t squared.
Right, that's what I got, and I just didn't know.
Well, if that's here, then you have a place to put
So
it.
would you just always do that for...
Yes, anytime you're missing terms, you represent them with 0 of those things.
And then what would that be? 0t squared minus 3t squared?
You tell me, what's 0 minus 3?
Negative 3?
Yeah, so you get negative 3t squared. Bring down 0t. Right? Keep going. Yeah. Yeah.
I don't know.
Oh, I just was asking you, why did you do long division? You could just take it since the bottom is one term. So everything we've done so far, the bottom had how many terms? If I had like 4xy squared minus 11x cubed y divided by 2xy, would you set this up like this?
No.
Shit, no, right? Shit. You just break it up. Why is this easier? Because the bottom is only one term. That's going to be easier. Okay. It'll still work if you set it up, but some of those problems, it won't work. If it was this, long division wouldn't work. Because you can't make 7y's go into 1y. Have fun with that. So it's much better to break it up and reduce. Why did we have to invent long division of polynomials for when the bottom isn't one term? Then I needed a new way to do it. So this isn't there yet. This is easier. Break it up, reduce.
So then on the practice test, you would reduce example I normally, and J would be long division.
Beautiful. I love it. J would be long. You should do J long and synthetic just to get practice both ways. Because on the actual test, I'm going to ask for both.
Okay.
Yep.
1J?
1J. A 1J. Do it both ways. Do it both ways. Okay. Yes.
5, 9, number
5-9 questions I'll take
5,
afterwards.
Oh.
It's extra credit, so I'm not going to.
Oh, okay.
Yeah.
Since it's extra credit, does it have to be completed before Thursday, or?
Oh, good question. No. I will have a question in the bonus section from 5-9 since it's extra credit. But extra credit I normally make it due the day of the final.
Okay.
Yeah.
You said it's through 6-3?
Say again?
6-3?
6-2. The test is through 6-2. Speaking of 6-2, I'm going to stop the questions there because we need to get into 6-2. We need to review what we did yesterday first. And I got a nice little handout that I'm going to force you into groups. Ah, so evil, John. To look at and do some stuff. So what we did last time was, there were two things we did last time. There was GCF, I call it the zeroth step, GCF. And then we did grouping. Four or more terms. Today we're going to do, the new thing we're going to do today is what to do if there's three terms, where the first number is a 1. We're going to cover that. After this next test, we'll do the rest of the factoring forms, so you know all of them. All right, so let's do some examples of this one. So if I had a problem like, what is it, Jeff? The instructions would say back. I have a special place in my heart for people that say, all right, this is 42, A4, B3. Are these like terms? Hell no. But how do I factor this? Probably this way. What does GCF stand for? Greatest common factor. Biggest thing that's in common for all the pieces. So the numbers. What's the biggest number you can take out? 3. All right, that's 3, 5, and that's 3, 9. So 3 comes out of both. That's the biggest thing that both can give. What about the A's? How many A's can you take out?
1.
1. You can give 3. You can only give 1. So they can both give 1. That's the most they can both give. And then B's? 1. And then C's? He's got none, so you can't take any out. Because what you're taking out of both at the same time. If you try to take a C out, he's going to freak. I like it. Same way, if you try to take 2 B's out, he's going to freak. Right? So forth. That's why, remember, the shortcut was, for the variables, you take out the smallest, least power. Okay, so what's left in this term? 5? A is
Done.
gone. You had two B's, you took one. You had one C, you didn't take any. 27 divided by 3. You had three A's, you took one. You had one B, you took it. Okay. Relatively, that's not difficult. It's dividing. And why does it make sense it's dividing? Because if you went backwards, what would you do with this?
Multiplication.
You would multiply it in. So we're just dividing it back out. If you can pull this in, you should be able to take it back out. I like it. That leads to this, which leads to grouping. That's still GCF. How many terms are in this problem? 2. I love it. Right? There's 1, 2 terms. What do they? Let me ask this. Be very careful. Listen to me. Does either one of these terms have a B?
No.
No. Neither one of those has a B. I know there's people out there right now that are like, I'm not going to say anything, but there's a freaking B right there. Jeff? What the shit? But it's the same thing. Does 8 have a 4 in it? Yes, because 8 is 4 times 2. Does 8 have a 5 in it? No. But isn't 8 5 plus 3? So in it means multiplicatively. There's no B in either one of these. There is a B plus 4 in them. Yes, that I will agree with. So what can come out? B plus 4, because they both have, just like these both had a 3, so you took it out. These both have a B plus 4, so you can take it out. So what's left here? 5x minus y. Let's check it. B plus 4 times 5x is here. B plus 4 times negative y is here. Check. Okay, I like it. So let's look at this grouping weirdness. Let's do it over here. So here, what if we had, it's always interesting trying to make one of these up out of nowhere. All right, let's see if I made one that works. What tells me to try grouping here? There are 4 or more terms. I love it. We're going to learn what to do when there's 3 terms. We're going to learn what to do when there's 2 terms. How many terms for GCF? It don't matter. That's why I call it the zeroth step. You do GCF first no matter what. So does anything come out of all 4 of these? Hell no. Well, actually, yeah, there's one thing that comes out of all 4.
Why?
Y. I like it. So if I take a Y out of everybody, let me see if I did this right. Yeah, I should have. Oh, I see. Here, take that last Y away. All right. Give me a little break. I got to think like 2 steps ahead for this to work. So, all right, let's try this again. Does anything come out of everything? No. Okay. Well, that is the first thing you look for. Just like that problem, remember that had the t cubed, the t4, that 5th problem on that paper? If you took a t out of the way first, you wouldn't have had it to remember at the end. I think it was 1 t, yeah. So here, nothing comes out of all 4, so you group it. Now, I've had teachers teach to put parentheses, but if you put parentheses, you took a negative out, you got to change the sign. Oh, that's some shit. So just underline them. So what comes out of these 2? Y. And what's left? Okay, cool.
What is that after the 5?
5xy. I can't make it any better. Yes.
Why don't you repeat the square first?
I had 2 y's. I took 1. See, you gotta love how you can just say that to yourself. I had 2 y's. I took 1, so I got 1 left. I had 1 y. I took it. Oh. Now, I really want this. Whatever this is, what's the only thing this could be for this to work? What has to be here? This! So what do I take out of negative 40x squared y to make it become 5xy? Negative 8. And do you see how that's what these have in common? They have an 8. How do I know to take a negative out? Because it's supposed to be positive 5. So take a negative 8x. And what do you get? Negative 40 divided by negative 8 is 5. You add 2 x's, took 1. And the y didn't touch. 48 divided by negative 8. And they had an x and I took it. So does it look like it's on the right way, on the right path? I like it. If that was a plus or that was a 10, you can't do another step. What's the reason I can do this next step? Why can I do this next step? Because these are the same. So don't do another step if they're not the same. That's what allows me. What am I actually doing on this step? Taking the common thing out. If there is nothing common, how could I do that step? Let that make sense. So what comes out?
5xy.
Yeah, that's 5xy by 6. That's what they both have. They both have that. So if I take it out, I'm left with y minus 8x. Check it. This times this is there. This times this is there. Bodacious. So that's grouping. When do I know to do grouping? After I check GCF, and if there's 4 or more terms, I do grouping. Let's try one with 6 terms, and then we'll get into some new stuff. 6 terms. Can Jeff handle this? I don't know. We'll find out if I can make one. Turn back this way. Let me make it easy for myself. There you go, Jeff. Sounds good. So the instructions are going to say factor this. So any GCF across the whole thing, anything goes into everybody? No, all right? They don't all have C's, they don't all have A's, they don't have all 4s, they don't all have X's, they don't have all anything. All right? My grammar's interesting there, but I won't. So what do? How many terms are there? 6. 4 or more means group. So the first way you try to group it is by pairs. Later we're going to learn to group it 3 by 1. We don't know enough yet. So what comes out of this group? 4. I like it. And then what comes out of, how many terms do I have now? 3. I grouped 6 by pairs, so I end up with 3 terms. What's in each of these 3 terms? So what's left? 4 plus a plus c squared. Check it. That times that is there, that times that is there, that times that is there. You gotta love that shit. That's why you say 4 or more terms. You try to group it. You first try to group pairs together. On this first test, that's really the only grouping I can give you. On the next test, I can give you a problem where you have to group 3 by 1. Don't worry about that yet. Okay, so that's what we did yesterday. Here's what we're going to do today. First off, let me do a couple things going into this. Just a couple examples of what I want you guys to do. It's going to sound a little weird, but I could have asked you this question on the first day of this class. What 2 numbers multiply to 60 and add to 23? Don't say anything out loud. Think about it for a second. Don't say anything out loud. Think about it. So notice, there's two restrictions on these numbers, right? If I just said multiply to be 60, that could be 10 and 6, 30 times 2, 15 times 4. Right? You guys with me? But I said they also have to add to be 23. So one way you could do this is to take 60 and go, okay, that's 4 times 15. Okay, that's 6 times 10. That don't add to 23. That don't. You just keep going, right? Another way you could do this is, what adds to be 23? 20 and 3. And so you can make a list of 18 plus 5 is 23, but that doesn't multiply to be 60. 20 and 3 is 23. 20 times 3 is 60. This seems very disconnected right now. I understand that. But this is a huge ability to have to be able to factor things that look like this. Let me show you one reason why, and then I'm going to give you this handout to work on. Help me out. What's x minus 2 times x plus 7? X squared plus 7x plus 7x minus 2x minus 14. X squared plus 5x minus 14. Where did negative 14 come from? These two numbers multiplied. Where did the 5 come from? These two numbers added. Intriguing. All right. So, don't worry. I want this to help you make a connection yourself, and then I'm going to come back in and make sure that connection was made. I don't like to do this too much. This always feels to me like lazy ass teacher. Here, student, teach yourself, and then I'll see if you got it right. But in this case, I like it. You might buy into it a little more if you come up with it on your own. Please find at least one other person to work with. Look around. Everybody's a nice